Test, test. Okay.
Hi there.
Hello. I
Uh,
am.
would we be required to turn on our cameras today for our interaction with Kush? Or
Um, I leave it up to you.
all right.
Are you
Oh,
if you're uncomfortable doing it, or certainly if you haven't cleaned your
no, I don't think it's a matter of uncomfort. It's just I didn't realize all this time we'd been saying the name Kush Kush. I didn't realize his name is Kush. It means happy back home. I finally did, so I did some research a little bit of yesterday and stuff like that. And I was actually I was fairly intrigued. So this is gonna be really dope actually.
cool. Well, and I am looking for the questions. I am going to need somebody to ask Jacob's question because he is unable to make it.
I technically still haven't submitted anything for that. I plan to probably do something after that. But if you want, I can take over that.
You want to do that? You can see the questions in the forum, right?
Yeah, I can. I should be able to. Let me just check real quick. Uh, yeah, it should be this one. Yeah, one good question. Dr. Varshney. You said Jacobs, right?
I think it's Jacob's. Let me just double check my email, but I'm pretty sure it was Jacob who emailed me and said he wasn't going to be able to make it. And now I'm looking for that email. And there I am. There it is, Jacob. Yeah.
Yep, I got it. Among the many types question. Yep, I got it.
Cool. Yeah, if you want to ask that one, that would be fine. That'd be great.
I think I have too many. Here's the thing, though. I kind of gave a look at the forum, and I feel like my questions that I came up with, I still have to post are very too specific now. So I don't know.
Well, and it's entirely possible that we will start doing the questions. For all I know, we might not even get to the questions. He may have a few things to say, and that might just lead us off in another direction entirely. And I am perfectly okay with all of those kind of possibilities.
I'm just looking forward to talking to someone like this. I mean, if I want to talk to someone with IBM, I guess I could have a conversation with you as well. But
Well, I'm not. The thing is, I now haven't been there in 7 years, so it to realize just how far removed I am now is, you know,
but would you
it's
like visit the occasional office party? Because as far as I know, your wife still works, or am I misinformed?
that is true. And so, pre-COVID,
Yeah, I was
actually,
about to say.
pre-COVID, the answer to that was absolutely yes, as well as the fact that a couple of coworkers and I would get together for breakfast from time to time.
That's
Um,
nice.
just kind of get together and shoot the breeze and chat. And I would pump him for rumors and stories.
Ah,
The just well because the thing is, um, they haven't hired anybody in quite some time, so it sort of turns out that just about everybody who was there when I left is still there, and largely doing the same things they had been doing.
well, Professor McCullen, if it wasn't obvious by my interest in IBM, here's to hoping that you know when I try to apply, something happens. But
Well, and so that's we should talk about that as a separate topic sometime. You and I,
oh,
um,
absolutely.
we can sit down and have a chat about that because I can give you some pointers, and I think the thing is IBM is such a big company
Oh
that
yeah.
when people say, "Oh, I want to work for IBM," my first question is, "So what exactly is it you want to do?" Because
Hmm.
there are working for IBM means a lot of different things. It means everything from being on call and, on call to fix customer problems with systems, to be doing research into AI and quantum computing. So,
Yeah.
that's one of those things that it's like, for instance, the group I worked in,
Mhm.
we exclusively recruited master's and PhD students.
Oh wow. Okay.
Um, because what we did was highly algorithmic.
hmm yeah, makes sense. I
So
wouldn't be surprised
I'm
if.
expecting us to have a few guests as well from CSC 372. I think Chris Morales was sending was going to send the Zoom link out to his class. He was actually debating whether to give them extra credit for coming to the session, but so far I haven't seen anybody from that group. So, and I'm also monitoring my email just in case, like if Dr. Varshney can't get in or something, I want to make sure that I see that. It's like, yes, oh, we decided not to let you get into the Zoom link, because the Zoom link it does not, the way I have it set up, it should not require authentication. There we go. I'm just setting up a couple of screens here. So in case I want to show anything. All right. There he is. Let's invite him in. Hello.
Hey, Kevin, can you hear me?
I can hear you. I
Can
am
you see me as well?
I can see you as well. And
Great.
I assume you can see me. I am
Yep.
actually just looking for the most recent email you sent me. I was almost like, I thought I was totally prepared, and then I realized I was missing something. There we go. So far I have students from my class. I have most of them are here. I'm expecting a few students from our ethics course as well, who may drop in. Their professor actually offered them extra credit if they I think offered them extra credit if they drop in. But it's 2:00. My 2:05 is probably more likely to be when everybody finally arrives. I don't know. It's like I recall meetings at IBM. A lot of them started closer to 5 or 10 minutes after the hour.
Yeah, in the research division for sure. When it's with other business units, they usually start on time, so we show up a few minutes late for this. Yeah.
It's fine. My wife, she works for IBM Research out of the Albany Nanotech.
Okay, nice.
And what I find when I listen to her in the other room is that she is usually, if it's with one of the partners, whoever they are, I don't know who they are because I'm not there anymore. And so it's one of those things where I don't even necessarily, it doesn't matter to me as much. But it seems like those start right on time, and the ones within her own team are a little more flexible.
Exactly.
So what I would like to do is I want to introduce you to the class, and then I'm actually going to ask each of the students to introduce themselves. We've still got, let's see, I'm waiting for one student, and one just emailed me that they are not going to be able to make it. And actually, I should ask you a question, because I always forget about that. Are you okay if I record this?
Yes, absolutely.
Good. Okay. Mainly because I hadn't even thought about it, but I set all my classes up to record automatically.
Yep.
And then Jacob was like, please record it. So he can check it out later. So let me introduce you. I'm gonna read some of your bio that you sent me.
Sure.
So Dr. Varshney is from Syracuse, and he earned a BS in electrical and computer engineering from Cornell. Go electrical and computer engineering. That's my field, actually.
Yeah.
A Masters of Science and PhD in 2006 and 2010 from MIT. And you are a distinguished research staff member and manager at IBM Research at the TJ Watson Research Center in Yorktown Heights. And I just have to say, in my career at IBM, I got to visit there sometimes, and that was like Toyland. That's
Yeah, and I haven't been since March, except for one afternoon for 2 hours, and that was like it was so refreshing to be back in the office, just even for that little amount of time. So
I remember going there for a meeting, and we were walking down a hall, and there was an electron microscope in the hallway. And it
I'm
was like,
sure.
they have the coolest toys here. I do have to ask, do they still have the coffee cart that goes around, and you can look up online when it will be at your area?
No, actually, about 2.5, 3 years ago, they started having free coffee where they used to charge before. So with the free coffee, they have it in one central place. So yeah.
Okay, so this is what's really important for our class is that Dr. Varshney is the founding co-director of the IBM Science for Social Good initiative. He applies data science and predictive analytics to human capital management, healthcare, olfaction. Is
Yeah,
that
the sense of smell?
sense of smell? I thought so. Yeah. Computational creativity, public affairs, international development, and algorithmic fairness. And I'm going to forward the rest of this to the class.
Sure.
Because you have a very distinguished CV, and so I would like the rest of the students. I'd like you each to introduce yourself, what year you are, and what your major is. And I tell you what, we'll do this the way we've done it in the past. Lily, I'm going to ask you to go first, and then if you could just throw it to the next person.
Sure. Hi, I'm Lily. I'm a freshman, and my major is geology, but I'm going to be teaching it. So, yeah. Joey.
Hi there, my name's Joey. I'm a computer science major, and I mean, I guess that about wraps that up. Let's do Brendan.
Hey, I'm a sophomore. My name is Brendan, obviously, and I'm a nursing major. Ian can go.
Yeah, hi. Hi, I'm Ian. I don't know if my mic's unmuted or not because it's not showing me, but yeah, so hi, I'm Ian.
I can
Ian?
hear you.
Yeah.
Senior
But
technically.
it's
I'm an
very
IT
soft.
major.
Yeah, Ian, can you speak up? Oh, we can barely hear you.
I don't know if it's getting any better or not. Can you hear me any better now or no?
Not really.
Yeah,
No.
just a little bit. But go ahead. I heard that you're an IT major, so I think yeah.
Okay, yeah, I'm Ian. I'm a senior and I'm an IT major.
That was much better. So Ching, I think that leaves it to you.
Oh, okay. I'm Ching. I'm majoring in math and computer science. I am a freshman now. Yeah.
Awesome.
Okay. So Dr. Varshney, or should I call you Kush?
It's up to you.
I never know.
Yeah.
It's always awkward. And
Yeah.
it's my students
Yeah,
kind of
I'm good
split the difference.
with anything. Yeah.
So
Yeah, as long as I know you're talking. So I can maybe share my screen and then we can get started, or
excellent. Please go
all
for
right.
it.
Let's
Oh,
see.
I gotta turn that on. I always forget
Yes.
to. There
Yep.
we go. You should be able to share your screen.
Yep, I can share it now. All right. Are you guys able to see the screen?
It's coming in. Got it. Yep.
Okay, awesome. Cool. So yeah, please interrupt as much as you guys want. I do have slides, but it's only because it's easier to do it this way. But yeah, I mean, I always learn better when it wasn't slides. So excuse that. All right. So yeah, the talk or the presentation presentation. So the title is Developing Trust in AI and Machine Learning for High-Stakes Applications, and we'll go through and kind of understand what all of that means. And just a quick question, Kevin. So if I use the word like machine learning and stuff, do we assume that we know what we're talking about a little bit? Or?
Yeah, let me I'll tell you kind of where we're at. Is the students have been working through these two books, Weapons of Math Destruction and Technically Wrong.
Yep.
I don't know if you're from, they're both pretty
familiar with.
And
I'm
so
familiar with the first one, the Weapons of Math Destruction.
Yeah, so we've been talking about machine learning and such, but with the exception possibly of Joey and Ian, I don't know, and I don't know if either one of you have taken the AI course. So there's a high level qualitative understanding of what the term means, but not really a technical depth.
Okay, sounds good. So I have some things that might be a little bit too deep, but we'll get to those in the second half. So let's see how it goes. And yeah, again, feel free to interrupt at any time, right? So just in terms of motivation, so yeah, Kathy O'Neill has lots of different examples in her book. Here's a couple of others. There was a fatality when Uber was testing its self-driving cars and so forth. And the interesting thing isn't that there was a fatality, but what the reason for it was. It was because they hadn't set their false positive rate threshold properly. So there was a plastic bag floating around which it thought was something else. So that's kind of the interesting part here. You might have heard about this one, which is there's this algorithm called Compass, which is put out by a company now called Equivant, but before they were called what were they called? Northpoint, and it's been used for kind of in the criminal justice system as a way to do criminal sentencing as well as pretrial detention decisions, and it's been shown to have particular biases against blacks and women and so forth, right? And then another example here relates to a particular model, a machine learning model used in one of the hospitals in Pittsburgh. And it was predicting that patients that have pneumonia, patients with pneumonia have a lower risk of dying from asthma than the others, which is counterintuitive. And this was only happening because there were, there was a special program in this hospital which happened to treat those patients differently if they were asthmatic. And so they were only, doing better because they had the special case. And if you move that to a different sort of hospital setting that doesn't have that program, then it wouldn't work, right? So in general, when we're talking about machine learning and AI, we want it to be trustworthy. And the reason for that is that it is being used in lots of high stakes decision-making applications, whether that's when you're applying for a loan, when you're getting hired or getting promoted in a job. And this, by the way, is a picture of the TJ Watson Research Center, the second image from the left, where I normally would work. Right now, I'm sitting in my basement, which is in Austining, New York. So that's next to the Hudson River, just to the west of IBM. It's also used in educational settings for grading, for admissions decisions, and so forth. There was actually a pretty interesting case just a couple of months ago. They were using machine learning algorithms to predict whether someone would pass or fail based on the grades that they already had received, but they didn't take their finals and stuff. So people showed that this was actually biased. So students studying at schools that were traditionally lower performing were getting lower score predictions, which isn't what you want. and then criminal justice system, including the compass example that I mentioned before. Right? So when I ask, what does it take to trust a decision made by a machine? So the first thing that you would probably say is that you want it to be really accurate, like 99% accurate. In real life, there's never anything that's 100% accurate, but you want whatever 99.999% accurate, right? But that's actually not enough for me to trust the decision made by a machine. There's other things that I want. So I might want it to be fair, easy to understand, know whether someone tampered with it, whether it's accountable and stuff like that. Right? So this word trust is a bit weird. So if I ask any of you guys, so please unmute yourself. What would you say would make a person trustworthy? So if I were to ask you, do you trust me? If you say yes, what sort of characteristics would I need to have to make me trustworthy? So anyone want to volunteer anything?
If you wanna, well, if we talk, I suppose there's a difference if we talk about trustworthiness of humans versus trustworthiness of machines, because humans work off a basis of having other things than just logic mainly driving them, things like emotions, environmental factors, and stuff like that. So in order to trust you, it'd be a much more difficult yet easier process for a human to do versus with a machine where trust is kind of encapsulated from just accuracy and like not accuracy necessarily, but like predictability. If you can see that 9 times out of 10 a machine's going to do the same thing, that's kind of trustworthy. Whereas a human could do the same thing, but maybe that same element of trust doesn't exist.
Yeah, those are some good thoughts. Anyone else have any additional thoughts about people or machines? What makes us or machines trustworthy?
I guess like being honest and transparent.
Yeah, that's another good set of things. Anyone else want to volunteer anything else?
Feel free to call on them.
Call on them? Oh,
Yeah.
I think, yeah, 2 is good for now. I'll call on you guys later. All right. All right. So it turns out that in the organizational management literature, they've come up with these 4 characteristics that someone, a human being, needs to have these attributes in order to be trustworthy. So I think we heard a lot of these already, right? So you want the person to be credible or competent at what they're doing. Second is to be reliable. So this 9 times out of 10 sort of idea that if they're competent, you want that competence to remain in different situations as well. So not just, I mean, in a very narrow sort of situation, but they keep being credible in all sorts of different settings. Next is related to the transparency comment that we heard. So you want some level of communication back and forth with that person, that they're open, that you can have some sort of intimacy with them and so forth. And then the last is that they're not just working towards their own goals, that they are somewhat selfless, that they're thinking about others. So these would be kind of 4 characteristics that you need for a person to be trustworthy, and they actually do map to what you want from a machine as well. So any disagreement on these? So Ching, does these make sense to you as characteristics? You can unmute yourself maybe. Ching, did you have any thoughts on this?
No, not any thoughts for now.
No? Okay, so I assume that makes sense to you. Anyone disagree with this list?
Dr. Varshney, just one quick thing, if I may.
Yeah.
I understand the bottom 2 ones,
Please.
bottom 2 ones as being things that are technically measurable. I can understand how you could, like how you mentioned with reliability, doing 9 times out of 10. I can understand the same thing, credible and competent. But with the top 2 ones, what separates that from being measurable aspects versus being morals, or not even morals, but like attributable? Like, there's a reason why I say morals is because I just saw selfless. I'm just like, how do you measure that? How do you,
Yeah, no, that's a great question. So let's start with the third one from the bottom, the openness or the intimacy, how much you can communicate with someone. So that one, I mean, again, it's a question of how you measure, but I mean, if you and I can understand each other, if we can kind of actually, I mean, understand what each one is saying, then I think that is measurable. I mean, if you start talking in whatever Swahili and aren't able to understand what I'm saying, then I think that is measurable in some capacity, right? So so I think that is there, and it doesn't have to be verbal language. I mean, the fact that you can, I mean, be with another person and just, I mean, make eye contact and understand them or whatever is, I think, measurable in some capacity. And then on the selflessness side of things, this is actually a really good question, and let me answer it in a second. So let me actually tell you the mapping for these sort of things for machine learning or AI systems, and then I'll get to the selflessness, right? So the credibility or competence, we can measure, like you said, with accuracy. And then the reliability, there's various sort of notions that come in here. Fairness actually comes under this as well, robustness and kind of safety and these sort of things. The reason fairness is related to reliability is because you want the system to do kind of the same in all situations, right? And that includes for different protected groups, for men and for women, for blacks, whites, Asians, whatever. So fairness kind of fits there. Explainability or I mean, these sort of things are related to the openness that we talked about. And then coming to the selflessness question, right? So there's a whole field of AI called value alignment. And the idea there is how do you tell a machine system, an AI system, what the values of society are, what are the rules that are the morals or whatever that should be followed. And this is not an easy question, right? I mean, how do I teach an AI system that if I'm driving along the road, that if a deer comes out of the side, it's okay to cross the yellow line, but if I'm driving along and there's nothing like that happening, then it's not okay to cross the double yellow line and stuff, right? So this is just, I mean, a very straight, simple example. I mean, you're talking about, I mean, many more complicated sort of things, then it becomes very hard to actually tell a machine learning system or an AI system what those values are. So you're absolutely right. I mean, it's a challenging problem. There's work that people have done of how it is that we can express our values to the AI system. And if we can express our values, those have to be in some machine format, and then you can measure them. So it's not impossible, but it's hard as well. And then the other sort of form of selflessness for machine learning systems is how you're using them. So are you trying to use them for social good or not? And that is something that might not explicitly be measurable, but it does have something to be kind of have a criteria for. And in fact, when we ask what is social good, that's actually another good question because I mean, it's not so obvious what it is, but the United Nations in 2015, the member states of the United Nations, they ratified a set of 17 sustainable development goals. And they include things like no poverty and hunger, quality education, quality health, all sorts of different things, reduce gender inequality and so forth. And if you look at that list of 17 sustainable development goals, that is a measurable set of criteria, and it actually has these, I mean, sub-targets within them that are actually quantitative. So if you have a machine learning system that's improving any of those sustainable development goal targets, maybe that's a measurable thing as well. All right. So moving on a little bit. So I'm not Heinz tomato ketchup salesperson, but you'll see why I have this picture up, right? So it turns out that how machine learning is right now is very similar to how the processed food industry was in the I think the 1870s or so, right? When Heinz was starting up. So it turned out that Heinz was the first company to guarantee that they aren't going to use unadulterated ingredients in their sauces. They were the first to offer up their ketchup in clear glass containers when others were selling it in dark containers. They, over their history, innovated a lot on sanitary food preparation. They were also the first company to offer free factory tours open to the public. And then in 1905, they lobbied for the passage of the Pure Food and Drug Act, which then led to later standards and laws for food labeling, nutrition labels, and so forth, as well as tamper-resistant packaging. And they also had a social mission that they wanted to reduce the household chores that people had so they could spend time on other things, I mean, recreation or spending time with their kids and stuff like that. So at this time in the 1870s, it was this completely brand new concept that, oh, you could actually buy food that was already made rather than cooking it yourself. And so we're kind of in the similar situation now with machine learning. It's this brand new sort of technology which is doing things that we haven't kind of pondered before. And I'm glad that you guys are reading Weapons of Math Destruction because it's my running example. And Kathy O'Neill actually mentions this at the, I think the end of her introduction or someplace that she is working in the same tradition as muckrakers back at that time. So I think she mentions Upton Sinclair as well as Ida Tarbell. And so Upton Sinclair had this famous novel called The Jungle, which was illuminating about the processed food industry, and now this muckraking tradition continues today. The other image I have up here is a researcher from the Algorithmic Justice League, Joy Bulamwini, who we'll get to later as well.
So
and
I should tell you that we
Mhm.
we last week or week before we had a debate in class. We split up
Okay.
into two teams,
Uh-huh.
and it was based on her work and my high school debate experience.
Okay.
And the topic of the debate was whether there should be a governmental or non-governmental organization, an NGO,
Mhm.
to regulate equity and what was it? It was equity and accountability
I see.
in algorithms.
Okay.
So based on her Algorithmic Justice League.
Mm-hmm. Nice, nice, awesome. So you guys are well aware, so I'm not teaching you anything new. So the point to be made though is if we had this whole processed food industry and all the things that Heinz was doing, and we have this analogy now with the muckraking, what is it that we are asking of trustworthy machine learning and AI, right? So I have a list of things here, and I'll go through these kind of one by one in a sense. But yeah, I mean, we can just kind of stare at this for a second, and then I'll go through them in detail. All right. So the first is with data quality. So with machine learning, as you probably are already kind of realizing and understanding, the way machine learning works, it relies on training data, and that data can be quite flawed potentially. So a lot of data that's used right these days is labeled by crowdsourcing. So this is the idea that you have people who are paid to label stuff. You also do it in your daily life when you do those reCAPTCHA sort of things. You're actually helping train a machine learning algorithm. Right. So if you're, I mean, if you have your crowd workers, some can be confused, some can be maliciously doing bad things. So there's definitely, I mean, data quality issues that you have to deal with. Value alignment, which I mentioned before, is this really interesting problem. So the reason why I have the image on the left up on the screen is there was this experiment run by the MIT Media Lab, which was on titled Moral Machines, and they asked a lot of participants, I think close to 100,000 participants from around the world, to give their judgments on these so-called trolley problems. So the idea is you're driving down the road and you can either keep going straight and kill these people or turn and kill these other people. What would you do? So that is a way to elicit kind of the values of society. And the image on the right is this famous story about King Midas and the Golden Touch. And the point of it is that whatever you're interacting with machine learning or AI systems, you have to be very precise, because if you give a specification and there's any sort of loophole in there, the machine is going to figure it out and kind of exploit it. So in Midas's case, he asked for anything that he touched to turn into gold, which was not a well-specified request. And so even the food that he was trying to eat turned to gold. So you have to be very careful with this sort of stuff, right? Next sort of thing is on distribution shift. And sorry, I guess I should have mentioned this, what the analogy is. I forgot to do that. So the data quality analogy is to the unadulterated food ingredients. The data poisoning and adversarial samples, which I'll explain in a second, is related to the tamper-resistant packaging. The interpretability is related to the clear glass jars for ketchup. The fact sheets, which is a way of introducing transparency, is like the free factory tours. The regulatory affairs is like the lobbying for the Clean Food and Drug Act. The social mission corresponds to the AI for social good, which I'll mention later as well. So there's definitely, clear analogies. Right, so distribution shift is an important sort of thing. So the way machine learning works, again, there's training data. You have a model which learns from that training data, and then you use that trained model to make predictions in the future. And if the world changes, then your machine learning model kind of falls apart. And there were a lot of stories in the news about how COVID is completely changing everything. And so machine learning models that were trained on the pre-COVID world completely fall apart in the post-COVID world as well. So how to make sure that that's not bad for you is an important thing. Data poisoning and adversarial samples. So there's methods out there which can introduce imperceptible changes to an image, like this ostrich. It keeps looking like an ostrich, but it to the machine learning model becomes a shoe shop or a vacuum cleaner or anything else that you want, just by small perturbations and so forth. And you can also have things in the physical world. So the stop sign on the left, it's been marked up with some markings, and because of that, it's possible to fool the machine into thinking that it's a speed limit sign or something else. Right? Fairness, which we'll talk about more later, is the idea of unwanted discrimination against people who you don't want there to be systematic advantage or systematic disadvantage to given to various folks. And then interpretability or explainability is the idea of how it is that we as people can understand how the machine makes its decisions. There's different ways of doing this. Let me not go into the details for that. The idea of fact sheets is very similar to if you're going to a car dealership and look at the sticker in the window of a car that you want to buy. It has all sorts of information. So it has a list of features. It has test results in different operating conditions. So fuel economy is a great example. It has an average, but it also has a city and a highway number. So it's similar to operating a machine learning model in different conditions. So you want some reliability. It has all the safety sort of tests it's undergone and so forth. And we think that the same thing should be true for any machine learning models that are put out there. And we're working actively to create these things. And on the regulation side, there's a lot of companies that are actively lobbying various sort of legislatures around the world to kind of put controls on AI. And it's interesting to see. So Microsoft, for example, at one point was very gung-ho, we want to regulate AI very strongly. And then a couple months later, they were coming out and saying, yes, we want the regulation, but just this way so that we're still able to do what we want to do. So I mean, there's a lot of interesting stuff happening there, right? And then on the social good side, using AI to help address societal concerns, address the sustainable development goals and so forth. So these are all examples of projects that that our project that I co-direct has been working on. This is a subset. We've done about 34, 35 projects in partnership with various nonprofit organizations addressing poverty, hunger, health, education, various sort of topic areas. Right? So that was kind of like an introduction to this trustworthy machine learning sort of thing that I'm talking about. Next, I'll kind of talk about how machine learning happens in the real world, in practice, in industrial settings, and the fact that in order to achieve this trustworthiness, you really need to avoid taking shortcuts, and I'll explain what I mean by that. Right? But before that, any sort of comments or questions or anything that you want to discuss?
Anybody?
Let me call on someone just because I have that power. I normally don't have that power. Luke, did you have any questions or comments?
First off, that's abuse of power, but no, I'm good.
All right, cool. All right, so let's see what I mean by no shortcuts. All right. Okay. So first of all, what is or how is machine learning done in practice in industrial sort of settings? So the image on the right, it's kind of the life cycle of how AI or machine learning is developed. And there's different personas. There's a problem owner. There's a data scientist who I actually, unfortunately, copied this from a different set of slides. And the data scientist was colored blue, and he's blending into the background right now, but he should be where my mouse is.
I think he's down. I think he's.
Oh, the data scientist is here. Oh, actually, yeah, you're right. Yep, that's right. Okay, cool. Data engineer, and there's model validator and AI operations engineer. Yep. All right, so all of them have a particular role to play, and there's different stages in the life cycle of creating a machine learning solution. And in many ways, the problem specification phase is the most important because this is when you're asking yourself, so this is the problem owner and the data scientist going back and forth, saying, I mean, should we even be solving this problem? Could it be used to as an instrument of oppression? I mean, are there things that are happening that where we should just, I mean, just kill this this idea to even create a solution? And with the face recognition, which you guys I know now are familiar with, IBM and other companies came out a few months ago saying we're not going to do any face recognition anymore. So that can be a possible problem specification. Or if you are going ahead, should you be measuring only accuracy, or should you be measuring accuracy and fairness and other things? So there's a lot of, I mean, things to say in the problem specification phase. And the not taking shortcuts here is that a problem owner and a data scientist probably don't have the full picture, and you should involve diverse stakeholders, especially from marginalized groups, and take advice from them because they can point out things in your problem specification that maybe you and your problem owner didn't kind of see or didn't figure out. So, so that's the no shortcuts there, right? The no shortcuts in data understanding and data preparation. So with this, we have a lot of different things that can go wrong and different sorts of biases that can come in, and you should be aware of them when you're preparing your data. So we kind of talked about these a little bit earlier as well. And then this is the sort of interesting part. You also don't want your model itself, your machine learning model, to take shortcuts. So if I am looking at this image and the task is for the machine to write a caption for the image, so it states it as uh, whatever, it's a green hillside as with grazing sheep or something like that. But there's no sheep here, right? And what it's doing instead is actually using the background and everything else that where sheep usually are to predict that there would be a sheep here in its description. So it's taking that shortcut. Here in the second one, uh, there's, like I said before, there's these adversarial sort of perturbations that one can put in that are not visible to people, but they can make you, the model think that anything else is there. So this image to a machine might look like a teapot or anything else, right? So it's taking the shortcut of these like weird patterns that humans wouldn't see. Another example is with the machine learning model taking a shortcut is uh, classifying this as pneumonia by looking at this little tag thing that's in the image near the shoulder blade. So by doing that, because all the images it saw before of pneumonia patients were like that, so that's what it ended up doing. This is similar to the example I said at the beginning with the asthmatics as well, right? And then another one here, I had this extra sentence about someone else rather than John Elway or Peyton Manning or whoever, then it gets confused, right? So that's kind of, I mean, these things where it's just looking at this last sentence rather than the entire paragraph. So there's all sorts of things that can happen with machine learning models themselves taking shortcuts, right? And the way to avoid some of those shortcuts in modeling are these different pre-processing techniques that you can apply, different techniques that you can apply during the model training, and different post-processing techniques as well. So let me again not go into so much detail here, but for various of these shortcuts, there are ways to make the machine learning model not take those shortcuts, right? And then finally, we are at the evaluation stage. Again, take advice from a panel of diverse voices. And then in the deployment and monitoring, again, make sure that there's someone who's a chief risk officer or someone like that who's really testing these out, making sure not to just put stuff out before testing them. So, so all of those are important things to do. Right? So this is when you're actually, I mean, doing machine learning in practice. And now let me move on to some more fairness specific things. So these are all things that I've personally worked on. So that's why I wanted to share those. Right. So this is, so before getting to the actual examples, let's again just remind ourselves what we mean by unwanted bias or algorithmic fairness. So what we're talking about is that you have a machine learning model, it's discriminating. That's actually, in fact, what you want it to do. So when I say discrimination in a technical sense, it just means being able to tell the difference between things. So if any of you are from the Finger Lakes and you kind of go to a winery, right? People talk about, oh, he has such a discriminative palate, right? That you can tell the difference between these wines, right? So that's, I mean, it's not good or bad. It's just the property of being able to tell things apart, right? So discrimination is bad or objectionable when it places certain privileged groups at systematic advantage and certain unprivileged groups at systematic disadvantage, right? So that's the problem, and that is illegal in certain contexts and undesirable in other sort of contexts, right? And why does this happen? It's because there's unwanted bias in the training data, and that will yield models with unwanted bias that then get kind of baked into these models and then kind of are used in large scale settings, right? So why does it happen there? There can be prejudice in the labels. So if there was a human who was labeling things for you, that this person should get a loan and this person should not get a loan, they might have had some implicit biases in their mind that led to them putting that out into the data. They can have undersampling or oversampling. So maybe your data just doesn't have many people who live in Austining, right? So it would just not do so well on those people, right? And then there's also the problem specification itself. So sometimes what you say is the outcome variable, the thing that you're trying to predict, isn't really what you wanted the machine to predict. So a couple of examples there. And so there was a piece of work that came out in the last year or so, which showed that health insurance companies, when they are assigning sick patients extra care to prevent them from getting even sicker, they use the cost of the individual or the health utilization of the individual as a proxy for how sick they are. But it turns out that there's already structural biases in US society that African Americans utilize the healthcare system less for the same amount of infirmity. So their cost is lower, but they're sicker. So using cost as a proxy for illness is not going to do the right thing. It's going to lead to African Americans having less care provided to them. Right? Similarly, if you're looking at whether someone commits a crime or not, that most people, I mean, most data that exists is not whether you committed a crime or not, but whether you got arrested or not. And there's two things that are problematic there. So one is that getting arrested doesn't mean you're guilty. You could still be innocent. And the second thing is that people who live in places where the police are more active get arrested more. If you live in a remote part of the county or whatever where the police just don't go, you're probably not going to get arrested as much, right? So all of those things say that, I mean, the problem specification itself is important to make sure that you're not introducing unwanted biases as well. And then in the data preparation, there can be things where you just happen to kind of do some feature engineering or other things that exacerbate biases. Right? Okay, so now let's come to some of my examples, right? So you guys are familiar with Joy Buolamwini's work. So let's get into that and some of our work in which we were trying to actually understand why it is that that this was happening, right? So first of all, there's lots of different vision tasks that have to do with people's faces. There's face detection. So on the left, this is Ellen's tweet that broke the internet, I believe. And so the task is to just locate all the faces. Where do they exist, right? So there's actually one missed in here. So this face has not been detected right here. Okay, there's the attribute classification task of the face. So is this a woman or a man? Is the person smiling or not? What's the age of the individual? Stuff like that. So this was the gender classification task here was what Joy Buolamwini's work on with gender shades was all about. There's the face verification task, which is I'd have to prove that I'm the person I say that I am, but the system knows what I look like. And then the last one is the face recognition task, which is the system has like whatever millions of faces, and it needs to take, test from that who you are. So all of those tasks are different tasks, but all of them these days are based on deep neural networks. Okay. So what Joy did in her work, so she had two papers. One was called Gender Shades, which came out first. That was in February of 2018. And the second was Actionable Auditing, which came out in January of 2019. So this is the second of the two. In the first work, she was able to show that the error rate in the gender classification task of commercial face classification algorithms was quite high for dark-skinned females, and it wasn't so high for dark-skinned males, light-skinned females, and light-skinned males. The three companies that were in her first paper, IBM, Microsoft, and Face++, oops, improved their models in the year either before or after her publishing the paper, and other companies like Amazon and Kairos still had very high error rates on dark-skinned females in the gender classification task. Right? So the question that we wanted to ask and understand is, why is there that discrepancy? Why are dark-skinned females having worse performance? Because I mean, you might imagine there can be lots of different things. The most obvious is maybe there's something about the skin tone that just makes it harder for the machine to do. But we wanted to get a better understanding of this, right? All right, so this again was our replication of her results, and it was more or less the same that she had. We had about 18% error rate on dark-skinned females, and all these tiny sort of error rates on these other groups, right? So actually, if you just look at it, if the dark-skinned females and the dark-skinned males are I mean, both dark skinned, right? And so if with skin color alone, that was the problem, you would expect the error rates of the dark skinned females and males to be about the same, but that wasn't it, and we wanted to go into more depth to understand this, right? So if it is actually true that skin tone is the issue, then we should be able to get rid of the inequality by making the neural network invariant to the skin tone using some mathematical tricks from what's known as color theory, right? So if we uh, do something to take a given image, a given face image, and change its lightness or darkness, then if the classifier, the neural network, is keying in on skin tone, then there shouldn't be any, then the light skinned version of the same face should not have the bad performance, right? But what happened was when we lightened or darkened the face images, there was no significant effect on the classifier's performance. So pretty much stayed exactly the same in terms of its performance. So we could rule out that skin type is not the reason for there to be that discrepancy on dark skinned females. Okay? So the next hypothesis that we had was maybe it's the hair length. And the reason why we thought that is because in that particular data set that Joy used, 29 out of the 33 misclassified dark-skinned females had short hair. So the three on the left are examples of the ones that the system thought were males rather than females. Whereas some of the females that had longer hair were classified correctly as females, right? So specifically, we labeled all of the images in Joy's data set as either short-haired or long-haired. And we did, yes, find that dark-skinned short-haired females had a 25% error rate, and dark-skinned long-haired females only had an 8% error rate. And this was actually also true in the light-skinned females. So light-skinned short-haired females had a 10% error rate, and light-skinned long-haired females had just a 0.5% error rate. So our hypothesis was that it's the hair length that's doing the messing things up, right? So what we did instead was just look at faces that only show this part of the face and nothing else, so no hair at all. And it turned out that the classifiers continue to have unequal performance across groups when we just look at this part of the face. So again, it wasn't hair length that was the reason. Okay. All right, so then what could it be? We've ruled out this actual skin tone. We've ruled out the hair length. So what we did was we applied this algorithm called the contrastive explanations method to try to find out what parts of the image are actually responsible for the classification. And we saw that for the females, it was really keying in on the lips and the eyes and a little bit on the cheeks. So these are the individual parts of images of different females that it was keying in on, and this is the average. So you can see it's really focusing in on the eyes and the lips and a little bit on the cheeks. Oops. And with the males, it's keying in on the nose, right? So what we learned from that was that it was the redness of the lips and the eye makeup and stuff that was really, I mean, determining what was going on. So it wasn't the skin type by itself, it wasn't the hair length by itself, but it really was facial features like red and pink lips, the cheekbones, cheek makeup, and eye makeup that were causing this discrepancy. And the reason for that is that most commercial face attribute classification algorithms are trained on celebrity images. And the reason for that is because they don't have copyright issues and consent issues. So you can get a lot of celebrity images very easily and use them. And the discrepancy between what regular people look like and what celebrities look like is the greatest in dark-skinned females. Whereas for celebrity light-skinned males, dark-skinned males, and light-skinned females, the discrepancy between regular people and celebrities isn't so high. So, especially on the makeup aspects of things. So that's what we think is the reason for it. Right? So, in order to really do better, what you need is a training data set that includes a diversity of faces, including non-celebrities and folks from all sorts of socioeconomic sort of circumstances. So let me pause here. Any reactions, any thoughts on that?
Speak up. Come on. Ask some questions.
So like other than makeup, like what were other distinct features that made the celebrity data set like very different from actual real world data sets?
Yeah, that's all we could figure out was those particular facial features, like the real red and pink lips, the eye makeup and stuff. So on average, that was the main thing.
I would imagine you wouldn't want to take celebrity pictures to try to find things like skin cancer, mole
Yeah.
types.
Yeah, no, you wouldn't. And I didn't include the slides here, but we just completed some work on looking at fairness in skin disease diagnosis, both from dermoscopic images, which are like a special instrument with its own illumination that you put next to the skin, but also from clinical images, which are just regular photos that the doctor takes. And yeah, I mean, the result that we found with dermatology is actually completely opposite of what we found here. So even though dark-skinned images in dermatology are much less prevalent, most of the training data sets do include mostly light-skinned individuals. Despite that, the accuracy across skin tones in disease diagnosis is equal. So even if you're dark-skinned or light-skinned, the model is able to diagnose you at an equal accuracy rate. So yeah, that's a great point, Kevin, that you made. I mean, there has to be something different about the population that you're training on versus testing on to really cause those sort of differences.
Yeah, I guess I'm going out on a limb, but the thing I was thinking about is I have seen articles that articles somewhere that, you know, the perception of beauty tends to have to do with symmetry.
Yeah.
And that the photos of celebrities would predominantly be highly symmetric.
Yeah. Yep. And I'll actually show you an example of the so-called attractiveness of faces and how that influences fairness in a second. So, so I have one more example with which comes to that point. So, anything else that anyone wants to ask or discuss before I move on?
Just a bit of clarification, I suppose.
Yeah.
Like most machine learning operations, there's an input and a required output. You've been showing us a lot of that output. I'm just a little bit curious where, not necessarily specifically IBM, this doesn't have to be IBM specific, but where often do you find these images, these inputs? Where, I mean, is it just randomly sourced? Is there a dedicated organizations with databases filled with this, or just be curious about that?
Yeah, no, it really depends what task it is. If you're talking about face images, Most of
Face
those,
images
yeah.
would, I suppose, consist of part of this database that I'm trying to describe, but in general,
Mhm.
I suppose it's more about where the sourcing is from rather
Right.
than what is, in
Yeah.
the sources themselves.
Yeah, and it actually does depend on the modality influences the source as well. So if you're talking about like electronic medical records, those are not out there publicly, right? So that is sourced in a private manner from actual contracts and agreements that one has with the hospital. If you're talking about satellite images, right? So like you can just download them from the Google Maps API for free, like 20,000 per day, and they don't charge you anything. If you're talking about like I don't know, some like voter records or something else, some of those are public records that you can get, whereas other tabular data is very private. That's held by an organization. And on the face images or images of people specifically, there's a really nice article which you all might want to add to your reading list. It's by so one of the authors is Vinay Prabhu, and the other is Abiba. I'm forgetting her last name. Abiba Arhan, I think. And it just came out like last month, and they talk through all of the consent sort of issues that come up with data, specifically in the context of images of people. And yeah, I mean, if let's say you post your images to Flickr or did so like 8 years ago, and you happen to check that, yes, I'm offering up a Creative Commons license for it, then Flickr actually created a data set of face images and taking all the ones that had Creative Commons license associated with them. And they're legally allowed to do so, even though no one particularly consented for their use in machine learning algorithms for training. So that actually is one of the large data sets that's out there, is one of the Flickr data sets. But with celebrity images, that's another big source of images because they're from news articles, which again, or whatever, paparazzi images or whatever you have. And uh, images of celebrities are not protected by copyright. Yeah, I mean, there's a variety of sort of issues that go into it. Does that answer the question, kind of?
Yeah, first, basically, I mean, I think I'll definitely have more questions after all this is done, but I'll let you continue.
Okay, sounds good. All right, so a different example, this relates to that Compass data set that we talked about before, which was the predicting whether someone will commit a crime again, that's used in the criminal justice system. There's some math here. Let me describe it more in words rather than in math. So we came up with an algorithm that would apply to data sets like are used in Compass, the prison recidivism sort of data sets. So you have your original data. So X's are features. These are things like what sort of crime did you commit? What's your age? Things like that. Whether it was a felony or misdemeanor. Do you have any prior offenses? Stuff like that. And you have Y's, which are what happened to that person in the past, whether they did or did not commit a crime again. And then you have some sort of protected attribute variable like race, which would be D. And what we wanted to do was to transform a given data set that has certain biases, let's say against Black people, into a new data set so the D, X hat, and Y hat, such that in this new data set, you don't have those discrimination problems or the bias problems. And the way we did it was to so if any of you are familiar with this concept of statistical independence, what we wanted was the predicted outcome, the Y hat, to be independent of the protected attribute, the race variable. And that is the sort of thing that we want for fairness, group fairness. And we also wanted to make sure that we don't introduce any sort of things that are affecting individuals pretty badly, because when you talk about group statistics, you can have something that looks really nice on average, but then there's these 1 or 2 people on which the algorithm did something really bad. So we wanted to make sure that that individual distortion was not so high either. And we also didn't want to change the data set too much because you still want to learn the task that you're trying to learn, which is who is going to commit a crime in the future. So if we put all of that together, we're able to figure out a mapping such that we can change a data set so that if you train on it, it'll have less discrimination. Right? Again, let me not go into the details here, but show you what happened. Right? So if we take the actual COMPAS data set, this was how it was originally. So the top row is African Americans and the bottom row is Caucasians. The left column is folks who did not recommit a crime, and the people on the right are the ones who did recommit a crime. Right. So the first thing to notice on here is that how many people are one on the African American side, and how few of them are one on the Caucasian side. Right, so there's more ones than zeros among African Americans, and there's fewer ones than zeros on the Caucasian side. Okay, so this is what's showing us that there's bias. The colors just show you one of the features, so misdemeanor versus felony. Okay, so what our algorithm did without us telling it what it was trying to do, actually rebalance things such that the ratio of zeros to ones among the African Americans and the Caucasians was much more balanced than it was before. And it didn't change other features so much. So the misdemeanor to felony ratio, for example, stayed more or less the same. Boom. And now if I train a decision tree classifier on the original data set, then what I get is a decision tree in which race is a big component of it. It's the first, so prior crimes is the first feature, but then after that, race influences who's predicted to reoffend or not to reoffend. But then if I use our new data set, the one that we've done the fairness transformation on, this is the decision tree that we get, and it only uses the reoffense sort of feature. And for this example, I mean, it's somewhat simplified, but it's an actual training of a machine learning algorithm that was done. So this is real, but a little bit simplified for illustration purposes. Okay. All right, so the summary, and actually, yeah, let me skip this as well. So the summary for this is that you can do these fairness transformations on the tabular structured data to get into situations where you're minimizing the unfairness that results in the machine learning models. Right. So last example that I wanted to show is this other algorithm that we've created called the fairness GAN, and this comes to Professor McCullen's point about attractiveness, right? Okay, again, I'm not going to go into the details of how we did it, but just show you the results, right? All right, so the task here, so this is another celebrity face image data set called Celeb A. All right, so we had different sort of attributes related to a face. So one of the attributes is whether it's male or female. So male equals 0 indicates female just in the encoding. Male equals 1 indicates that they're male. And then this has an attribute called attractiveness. So attractive equals 0 and attractive equals 1. So attractive equals 1 means, and it's really interesting to read about the history of this data set, which was labeled by some like sweatshop in China or something like that, but that's a side concern. But these have been labeled according to like 40 different attributes, right? One of them is attractiveness. Right, so what you're seeing is in the center is the average face that corresponds to these two attributes, that it's female and non-attractive. This is the female and attractive, male and unattractive, and male and attractive. So whenever you average things, when you average a lot of images together, it does tend to do a lot of smoothing. So that's why these look kind of smooth in that respect. Right, and then what you see around this is the first standard deviation of that average face in two different dimensions. So So if you look to the right and to the left in the horizontal, that's one variation. So it's actually using what's called principal component analysis, if you guys have ever heard of that. So it's the first principal component. Then up and down is the second principal component, and then in the diagonals are combination of those two. So this is what's called an eigenface, and it kind of tells you what the distribution looks like of those faces. So, I mean, I'm not going to make a value judgment, but it seems like the more attractive male faces look a bit younger than the less attractive ones if you just look at it, and so forth, right? And similarly, I mean, the more attractive females, in my view, look, I mean, they have a little bit fuller lips and a little bit higher cheekbones, and the hair is a little bit less gray and stuff, right? All right, so then what we wanted to do was to ensure that the attractiveness was the same across males and females. So that was kind of the decision that we were trying to do. We didn't tell it what constitutes attractiveness, but just wanted to equalize the attractiveness across the groups. And what the system did was kind of interesting. So if you look at these males after the transformation, it does seem like they've become a little bit less attractive in some capacity, just by, I mean, having a little bit more kind of feminized sort of face structure and stuff. And it didn't do a whole lot to the females because the females were the so-called privileged, the unprivileged group in this case. So this is the sort of thing that can happen. Here's another example on a different data set. This is with people asked to draw a power outlet. And if you ask people in Great Britain to draw a power outlet, they tend to draw like this big box with like three things. Whereas if you ask someone in North America, including Canada or the US, to draw a power outlet, they would draw these two different, two power outlets on top of each other in a rectangle. So there was a system that could either recognize this as a power outlet or not. Among the Great Britain ones, it was mostly not recognizing these things as power outlets. And in the Canada ones, it mostly was. The ones it wasn't recognizing were a lot of scribbles that didn't really look like power outlets, and so forth. So then if we do this fairness transformation so that between Great Britain and Canada, we do improve the recognition rate for the Great Britain drawn power outlets, they do start taking on more of this North American character to them. So that's another example of this sort of transformation that we didn't tell it what it needed to do, but it kind of figured it out by itself to increase the fairness. Right, so last point I wanted to make was that we created this open source toolkit called AI Fairness 360, which any of you can go and look at the code and use it in whatever you want to do. It's a Python open source toolkit. And in our opinion, it is the most comprehensive bias mitigation toolbox out there. And I would encourage you guys to check it out if you want. And even if you don't want to look at the code, if you go to this website, aif360.mybluemix.net, there's a web demo that you can click through. And it takes you through a lot of this sort of bias mitigation sort of things in an interactive fashion. So my colleague Yunfeng really did a good job on creating that web demo, and I would definitely encourage you guys to check it out. So yeah, just to wrap up, we're almost at the end of time, so I think I paced myself all right. So we're kind of already getting very high accuracies on many narrow tasks through machine learning, and we really need something more for high stakes applications like criminal justice or lending or hiring or healthcare and stuff like that. So things like safety and security and transparency and fairness are very important for that. That gives us a lot of interesting problems to work on. I really enjoy doing this sort of research, and I told you about a lot of our fairness work, but we have a lot more that we've been doing, and we've also been developing a lot of new algorithms on interpretability and explainability and transparency, which if we had more time, we could have talked about. But yeah, just kind of wanted to end there. So any other comments, questions? Happy to go through anything that you guys want.
Well, they had actually, so to make sure they did the prep work, which was I had actually posted a couple of your papers in Moodle for them to look at, and they had to come up with questions, but they don't have to ask them. That was just, that was to make sure they did the prep work. So I'm just going to ask, because we're almost out of time. Do you have any questions? Come on, you got to have some questions. That's Luke. Luke is Luke.
Yeah.
It's funny. You had something you posted there, and I'll just throw this out. You talked about a risk officer, and it rang a bell with me because a friend of mine from high school just retired from the Air Force, where she had to sign off on the safety of all non-Air Force owned aircraft that were flown at Edwards Air Force Base.
Right.
And this idea of a safety culture that exists in other fields of engineering, but doesn't seem to have penetrated into some of these fields.
Yeah, no, that's exactly what we're trying to change a little bit. So a different word we use for our fact sheets is the supplier's declaration of conformity. So that's the technical term coming from other industries. So just to unpack that, so conformity means that any product is conforming, is satisfying regulations and requirements that a particular field has. Declaration of conformity is that someone is signing off actually within their name that yes, this thing meets that conformity requirement. And then a supplier's declaration of conformity is that the person who is creating that artifact is the one who's doing that sign off. You can also have kind of third-party testers who would do it as well. So yeah, I mean, it's clearly something that needs a culture change, and that's something that we're actively working on. And we have more of an incentive than other tech companies to do it, because if you're Google or Facebook or whoever, all you're doing is things for your own platform. You're not selling things to clients to use in their real world applications in various sort of industrial settings. So for us, I mean, it's very important to do more on that.
So if any of you got any questions, I think this was really cool.
I do have a couple of questions that I'd like to throw.
Yeah, please.
So the first one is, given your seniority and relative association with the IBM in terms of AI and data collection and data science, I have curiosity in terms of your affiliation with the Watson AI, because that is some of IBM's leading cutting edge technology, in the sense that it is, correct me if I'm wrong, it's a language comprehensible question input and output AI system. Is that how, that's how I've heard it described before?
Yeah, so there's many ways to answer that question. Right, so first of all, why the name Watson? So two of the early CEOs of IBM were Thomas J. Watson Sr. and Thomas J. Watson Jr. So that's where the name comes from. IBM Research is our organization. It's been around for the last 60, 70 years. And our building is called the TJ Watson Research Center. Right? So that is its own thing. And in 2010, IBM Research, our organization, we created a system to compete and win Jeopardy against two human players. And that was the name given to our system at that point was also Watson, right? And Jeopardy, if you guys aren't familiar, it's this TV game show, quiz show, right? Right. So after that happened, that was aired in February of 2011. This was just a few months after I started working at IBM. And so I didn't personally participate in it, in the development of it, but I have colleagues who did, because it was well underway when I started working at IBM. All right, so that was the Jeopardy system. That was exactly what you said, a way to answer questions in context based on a lot of documents that you can parse and so forth. Right? IBM wanted to, I mean, they got a lot of visibility from it, so they wanted to use that as a brand for all sorts of AI stuff. So they created a business unit called the Watson Group, IBM Watson, and started putting all sorts of different things into it, which are not what you said. So I mean, image stuff, all sorts of stuff. I mean, text to speech. I mean, all sorts of things were given the Watson branding. And so, and there's the Watson Health, the Watson for Oncology. I mean, all sorts of different stuff. And I personally helped on a project called Chef Watson, which was a way to generate brand new food recipes that have never been created before. So, I mean, they've been using this term, I mean, pretty wildly. And right now, what the situation is that there are these Watson APIs, which are some of the text-to-speech and some sentiment analysis and various things like that. And then there's a Watson Data and AI platform product, which lets practicing data scientists and companies develop their own machine learning tools and technologies and models. So right now, some of the fairness and explainability things that we've been working on, we've been working with that business unit to put those into the some of those products. So there's one called Watson Open Scale. There's one called Watson Studio. So that's the part that I'm personally right now interacting with the IBM business unit on.
That's actually quite interesting. It's actually interesting that you mentioned something like Chef Watson. It's a very common thing for computer science students over here to come up with programs relating to do with cooking and all sorts of very similar modern day activities. It's a really cool idea of trying to just apply that AI and machine learning application to something as menial and everyday as cooking. That's pretty cool actually. And if you don't mind, I just have one other question.
Sure, go for it. Yeah.
So in one of the documents that Dr. McCullen presented to us before this meeting was signal processing for social good excerpt, I believe.
Yep.
And in it, it kind of tells me that I've kind of got an indication that you're familiar with not just data accumulation and processes in countries like India and stuff like that. My main question has to do with I just want to see what your views were on government mandatory regulation of things like data and stuff like that, because we, as Dr. McCullen just mentioned, we did have a debate about that. And I was just kind of curious to see, in terms of the four attributes you were telling us at the beginning of this meeting, how would you apply that to a system like Aadhaar that exists in India? Just your opinions and views about that.
Yep, sure. One thing about India specifically, there's actually right now an ongoing web virtual conference thing that Narendra Modi is running. It's called RAISE, Responsible AI for Social Empowerment. And one of my group members, he gave a talk, I think either today or he's giving it tomorrow, in that, and the CEO of IBM, Arvind Krishna, gave one of the opening talks. If you just Google for like RAISE or Modi or something like that, you can watch the YouTube videos of all of that. But to answer the question, so Aadhaar, if I'm not mistaken, is like a national ID system, right? And
well, it can be pretty much summarized down to that. The only reason why I asked that is because technically, as we speak, Aadhaar is not only the world's largest database, as far as I know, in terms of recorded amounts of information, but it's also government regulate. Like they literally created a government department for it, and it's biometric data specifically. That's the most important part of Aadhaar, which is why I was kind of curious, since regulation and fairness about that is kind of your field. That's why I was kind of curious.
No, I mean, it's definitely important, and it relates to, I mean, your earlier question about kind of consent of using data sets and stuff. So if I'm not mistaken, there's quite a bit of encryption as part of that Aadhaar as well. So the biometrics are kept in sort of, I mean, encrypted format and so forth. So, I mean, there's various ways of protecting data. I think some of them, that particular application need to be kept under lock and key as much as possible with regulation, because you can't change your fingerprints, you can't change your iris scan and stuff. So so that is important there. Really, there is a role for government for sure. In the European Union, there's the GDPR, the Government Data Protection Regulation, or sorry, General Data Protection Regulation, which specifies a lot of data protections that are needed for private companies to follow as well. So, it clearly is a important thing for government to step in and take its role on, for sure.
So
All
anyone
right.
else have
Thank you so much.
anybody have a last question before we let Dr. Varshney go? If I recall my years at IBM, you probably have 4 more meetings today.
No, I actually have to finish a paper submission that's due tomorrow morning. So,
That's
yeah.
As a manager, that's not one you can just reschedule.
No. Yeah.
So do we have any other questions? Anybody? Lillian, Brendan, Ching, Luke? I do want to ask you one favor. Can you send
Sure.
me a link to the or the title of the paper on the consent
Absolutely.
information? I Googled for it. I couldn't quite find it. I found some other cool stuff, but
Sure, absolutely. Yeah, I'll send that to you right after we get off this call, and I can send you my slides as well if you want those, if that's useful.
cool. I can put them in Moodle. I showed you there briefly the papers that I showed them. The little
Sure.
red marks, I just want to warn you, the little red marks it had, that was just because Moodle didn't feel they were they didn't meet the accessibility
I see. Okay.
tests that they do.
Yeah, actually, at least one of them was published by the ACM, the Association for Computing Machinery, and they're instituting something as we speak, which will make all ACM papers accessible by next year. So that is in the works.
I didn't want you to think those were like, ratings I had put on them or something.
Right. Yeah.
Thank you very much for this. I really appreciate this. This was really cool.
Yeah, my pleasure.
And everybody, please, just let's at least say thank you. I know there's this goofy thing where we can do, what is it, the reactions? This is what everybody always does. It's like the little applause thing.
Right.
We're getting pretty handy at using this Zoom stuff.
Mm-hmm.
But again, thank you so much. I appreciate it. And next time you see John or talk to him, say hi to him for me.
Yep, absolutely.
He's closer to me here, but I probably see him less than you do.
Mm-hmm. Yep.
All right. Terrific. Again, thank you very much.
Yep. Have a good rest of the day.
Thanks. And the rest of you, I will see you all Monday.
All right.
Okay.